Hi, good morning, everyone. I was told that everyone is getting a little tired, and I was supposed to get all of us riled up and engaged in our next presentation. I'm Priscilla from the Infocom Media Development Authority of Singapore. I represent our organization in our initiative in the digital identity and verifiable credentials. Today, I'm very happy to share more about our initiative in collaboration with China and Hong Kong, which is a sandbox pilot that we're running to demonstrate the value of verifiable credentials, right, to enable interoperability of digital identity among these three regions. So maybe just to give a little bit of background of what we do in Singapore, we have provided what we call digital utility stack to enable citizens and businesses to transact seamlessly in the digital economy. We have provided 4 pillars of such digital utilities, which are actually more commonly known as digital public infrastructure in the rest of the world. The first one, of course, is digital identity. We have a centralized digital identity called SingPass and CordPass. So every individual that resides in Singapore is actually given a digital identity, which they are able to transact with the government or between businesses online. And we also have an equivalent for corporate identity called CordPass. The second pillar, which we have, is the verifiable credentials, which is basically a domestic standard which we've provided for businesses or for companies to send out documents and be able to attest the veracity of the documents that they send to each other. Currently, we're trying to work towards making it more globally compliant in terms of the standards so that it can be interoperable with the rest of the world. So which is why our team is actually working towards providing a VC version of both the identity as well as the method of attesting to documents. So some of our key initiatives in this area is exploring the issuance of a VC for citizens, individual IDVC, and corporate IDVC. As well as in the area of educational certs, we have something called Open Certs, which we are also trying to pivot to be W3C compliant. And in the trade space, we have heard some use cases across supply chain in the previous presentation. We also have an equivalent of that called Trade Trust, which enables everyone in the supply chain to be able to exchange documents, in particular the e-bill of lading, right, the title documents, in a way that is reliable and enables people to authenticate these documents easily. And the last one that we're driving in this space, which is quite new, it is to use verifiable credentials for notarization of our documents. So whenever we go overseas and we need to make applications, we are always asked to provide a document that has been verified by a legal professional, right? And the whole process of doing it today is very tedious, it's physical. We're trying to digitize this whole process and to use VC to make it simpler for everyone. And the other 2 pillars of our digital utility is the data exchange. So we actually have something called the DEX, which is a central infrastructure that enables companies to connect to this layer of data exchange, which then enables them to connect to many different parties without having to build a customized connection with every single party that they wish to exchange data with. And of course, under this, there are function-specific data exchange, like for financial data exchange, for trade data exchange, and for built environment. And the last one, of course, I think is quite straightforward for everyone, digital payments and invoicing. Basically, it's just a digital version of what we have today. So what we're trying to do is really to complement our centralized digital identity infrastructure to provide, to enable businesses to be able to transact more easily across the border, and also, of course, between businesses in Singapore. So how we see that happening is that SingPass today is, as we mentioned, centralized. And so it is intended to attend to very high security use cases, right? The typical financial use cases, healthcare, medical, and government services. And how we see that happening is that today we have users expressing perhaps privacy concerns with the government knowing where exactly they transact their private data, having because every single time they exchange data with a company, it actually needs to ping the central server to extract that data. And so we see VCs being able to address that concern. And at the same time, what we have provided today actually only allows users to exchange public sector data, which means that private sector data, for example, banking data, or other, or credit scores, all these are not actually information that the government holds in our central repository. So using VCs, they are able to actually enable private sector companies to also provide verified data and to enable users to exchange these data. And so we see the value of VCs complementing our centralized infrastructure to be able to provide for its utility in a wider range of use cases for the medium to low security use cases. And we know that today, the whole world, as we all have here in the audience, people from all over the world are shifting towards the use of verifiable credentials in various, all forms of use cases. And we see that that means the potential reach of user base using this same technology and how everyone, if we all move in this direction, we actually can enable interoperability to a different level of scalability that we have not witnessed before. And so what IMDA is trying to do in this next phase of work is really to explore how we can test out the business value of using VCs, and also, of course, the technical feasibility for businesses to use this for transactions with citizens and also with other governments. So in the first phase, we're exploring use cases that allow us to streamline access management, right? Today, we may carry many different cards, membership cards, staff cards, student card, and basically, we don't really want to carry so many things in our wallet. So is there a way for us to streamline all these using VCs to be able to hold it in our digital wallet and to be able to access places freely and easily using our VCs? In the second phase, we are exploring how we can use VCs to improve eKYC to prevent fraudulent transactions. I think today, all of us face various challenges in our online transactions. We don't know whether it's scam or not. In fact, in Singapore, we are known to be the scam city. Not that we scam others, but we appear to be targets of scams. So this is really something that is very important for us to explore, how we can use VCs to verify the identity of the people that we're transacting with, whether the business is a legitimate business that we're purchasing from, whether the person that we're transferring money to is someone reliable. So we are trying to establish the ability to issue corporate identity verifiable credentials so that when businesses transact with one another, they can authenticate, right, or even check the credit history of this particular business before they transact with them. And in the last phase, we are thinking of exploring the use of verifiable credentials to enhance cross-border interoperability. And this is how we intend to do it. We have various pilots, for example, the one that I mentioned earlier about using verifiable credentials for the notarization of documents to enhance the reliability and also the efficiency of checking these documents. And also, of course, across borders, in the sandbox that we'll be sharing more later, is how we can verify our identity with another country to demonstrate that I am who I claim I am, and I'm a citizen of the country that I say I come from. So if we assess, right, after all our pilots that this is indeed feasible, IMDA will then explore the provision of VC as yet another digital utility that our businesses and citizens can leverage. Right now, we have a domestic standard, which I earlier shared, called Open Attestation. It is basically a standard that we use for the exchange of educational certs within Singapore, but we're working towards pivoting that standard to be globally compliant so that it can be interoperable with the rest of the world. And in the next phase of work, we are also exploring the provision of a digital trust service. I think in the issuance and the verification of VCs, it's important to be able to tell who are the trusted issuers that I can trust when I receive a VC and I would like to verify it. And of course, right now, we actually have already provided a Trust VC library, which is an open source code that allows issuers or companies to test out issuing and verification functions by leveraging these open source codes. And in terms of building the ecosystem, we need to think of both building the demand and the supply. So in terms of the supply, we have, of course, our existing centralized digital infrastructure, SingPass, and we intend for that to be the issuer of the individual IDVC, and our business registry, which is ACRA, to be the issuer of the corporate IDVC. In terms of the provision of wallets, I think there was a lot of discussion about wallets in the earlier segments. We are exploring accrediting various wallet providers, whether it is OS native wallets or even companies that choose to provide proprietary wallets for people to hold their trusted credentials safely and exchange them safely in these wallets. And in terms of the use cases I've shared briefly, we are exploring use cases in all different sectors to demonstrate that it is indeed going to be valuable, not just in healthcare, but education, and also in staff card or business document transactions. And for non-identity use cases, I think we also have shared earlier about the notarization use case, and also in the trading industry, the e-bill of lading. So in this next presentation that will be shared by our technology partner, RedDate Technology, we would like to just demonstrate, right, the value of this sandbox pilot between China, Hong Kong, and Singapore. Basically, this sandbox is supported or overseen by the various government agencies in Hong Kong, China, and Singapore. So with the State Information Center supporting China Mobile, with Digital Policy Office of Hong Kong supporting Hong Kong Telecom, and with IMDA supporting our technology partner Accredify, we are exploring the use of VCs to allow citizens in these three regions to verify their identity and to use it for various use cases. For example, in verifying, in opening a bank account across the border, or in crypto transactions across the borders. And as part of this SingVC, as mentioned, there is oversight and management by the various government bodies, as well as we have a platform operator, which is Accredify, and we have RedDate Technology, who is the technology provider of this entire platform. And of course, it's supported by the blockchain infrastructure, Solana, and also the verification infrastructure is provided by OpenDID. So I'll hand the time over to our technology partner, Yifan from RedDate Technology, to share more about the sandbox. Thank you.
Thank you. Let me do a very quick introduction. I only have 10 minutes. So we are a Ready Technology, Hong Kong-based company. We actually build a lot of decentralized technology infrastructure. So we build China's BSN infrastructure, the China Real DID infrastructure. We build the Hong Kong government's shared blockchain platform. We build the SIM-Pass with IMDA. So we are a few companies with track record to build government decentralized technology infrastructures. Sorry, it doesn't work. Someone help? Hello? Oh, okay. So this is actually Singapore's state secret, okay, the SIM-VC architecture. So here you can see there in the middle, actually think about this as an extension of the SIM-Pass. So we basically built a new platform, so it actually supports multiple apps, not only the official app. So any app have access to SIM-Pass, you can actually become a wallet, holding and applying DIDs and the new VCs. If you don't have access to SIM-Pass, you still can be a wallet to holding the VC and present the VC. So also this is a multi-issuer platform, which means any business can apply, become an issuer of the platform and issue government-backed VC linked with SIM-Pass DID. So, and also the very important aspect here is we actually put all the verifiable data on Solana public chain. So this is not the VC itself, it's the verifiable data like the VC's hash, the public key, the DID address, everything, so no personal data on chain or on internet. So all the VC under the issuer actually use open source toolkit. They download from GitHub, build locally, manage all their VCs and the templates, and also, basically communicate with the government system. Everything is open source. When we release the open source, you can download it and build your own VC system immediately. And also because the verifiable data is on public chain, so the verifiers don't need to connect to the government system. So they just go to Solana and verify everything. So this is literally make everybody in the world become a verifier. God. Okay. Okay, this is. Okay, so we actually also support all the popular VC formats. WCC standard SD, JWT, and also MDL. And we also offer, when the VC issuer, when they choose, they can also choose to create a template with regular VC or zero knowledge VC. Of course, zero knowledge VC is pretty limited, with the logics, yes or no, or older than some number, or a little bit limited. But if you need to contain some personal information, like exactly number of balance of your bank account, then you have to choose a regular VC. But all the VC, when they issue, because the issuer knows the end user's DID address and the public key, so everything is encrypted. Only the end user can decrypt it. And the government CVC platform, what it do, it actually runs pretty automatic. No need of maintenance, because it basically validates the issuer is the issuer, end user is the end user. That's it. So this is basically the benefits of the VC technology, DID technology, and the digital identity technology. First thing is, think about this. Today, how we verify each other, we basically read a physical ID or compare a signature. It's literally 3-year-old technology. It's 3-year-old. It's 21st century, okay? That's why it's a shame on us, okay? We still use this old technology. But the VC technology, truly what we're trying to do is change the human-read data to machine-read data. Okay, so it goes fast. Because human-read, when you read a physical ID, there's no way you can guarantee it's real. How? Especially as a foreign document. How? So the second one is, because when human read, it needs to be a plain text, so it's personal data. When it's machine read, you basically can read a cryptographic data. So there's no personal information there. So it's privacy enhanced. Also, this one actually very important to governments. We expand the verifier base. Because it's a centralized digital identity government system, you need registered verifiers. They need to connect to your system, and you give them yes or no answer. But we put the data on public chain, which means everybody goes there to verify. And remember, when you verify something on public chain, you don't need to pay gas. It's free. It's free public infrastructure. We actually give the meaningful purpose to public chains beyond cryptocurrency. And also return the control to identity holders. Why? Because the government is very powerful, right? They issue identity to you, then you go to a verifier, and the verifier need to connect to the government system to verify. So the government knows you, knows the verifier. But now if a verifier go to a public infrastructure to verify by themselves, basically cut off the verifier connection to the government. So who knows everything? The user. This is actually shift the power from the government to end user. And the next one, very important to governments, because the verifier don't go to you, you save a lot of cost. If you really maintain a large government identity system, you know it's very expensive to serve verifiers. Okay, let me quickly go. So the use case, very quickly. So the first use case is we enable all the crypto or stablecoin Web3 wallets. They can actually link to a government DID. Zero knowledge. Okay, and most issuer will host all the end user private keys, but you keep your identity key. So which means there's two-party control that wallet. So any transaction is KYC'd, any wallet opening is KYC'd. So this is the only technology today you can enable to KYC an on-chain wallet without exposing personal information. This is travel rule. And actually, the travel rule doesn't work. I mean, when this bank send a name to another bank, how that bank verifies the name is real? Today, actually, it doesn't work. It's a rule. You just send a name. They say, OK, it's from bank. We trust it. So right now, we're actually developing a use case is a touch. A government-issued travel rule VC with a token transaction or even SWIFT message. So when the receiving bank receives they can actually verify the name is real. It's a government-issued name. This is also a use case we actually try to change the end user behavior to input data online. So this is actually, you don't need input data to the form. You actually submit a VC issued by the Singapore Credit Bureau, a credit VC. Then the website reads the VC, input the data automatically, and process it in a second. So in the future, when you input your name, your credit card number, your proof of address, all the things, you actually read from VC, which means the data is verified before you even input them. It's a huge change on online behavior. Thank you.